So last we left off, we were talking about formula mass, right? I believe left off here. Calculate the formula mass of ammonium nitrate. So how would I go about doing this?
Write the chemical equation.
Okay, so what is the chemical equation for ammonium nitrate?
Would parentheses go first before ammonium?
I don't know, you tell me.
Ah, wait, let me get this.
Alan, are you trying to solve it?
No, I'm just trying to find out if there's any number after ammonium, since ammonium is a 1 positive charge.
So what is the chemical formula for ammonium?
NH.
NH4.
At H4. Okay, what about nitrate?
NO4?
So that's balanced.
And
NO3.
NO3.
NO3. And it's balanced. That's right. Because we know that ammonium has a +1 charge and the nitrate has a -1 charge, so it balances out perfectly. Okay. So that's my chemical formula for ammonium nitrate. So how would I calculate the formula mass?
Oh, you go to the periodic table and check the elements atomic mass
Okay.
on the MU.
Okay, so what elements am I going to be looking for and how many?
Nitrogen, hydrogen, and oxygen.
Okay, so am I just going to get the mass for nitrogen, hydrogen, and oxygen?
Yes, but we have 4 hydrogens and
Okay,
3 oxygens.
and 3 oxygens. And how many nitrogens?
2.
2. Yeah.
2. Okay, so what is the mass, the atomic mass for nitrogen?
It's just 1.
14.
Oh, nitrogen. Oh yeah, 14. My bad.
And there's 2 of them?
Yeah. 28.
What about hydrogen?
1.
That should be 1.
And there's 4 of them?
Right.
And oxygen?
16.
And there's
That's
3 of them?
8.
Okay. So we add it together.
That's 80.
Oops. What units?
MU.
AMU.
AMU. Okay. Piece of cake?
Piece of cake.
No.
No. What's the problem, Christina?
The addition doesn't seem right. 8 plus 8 would equal 16, not 0.
+4.
Oh, okay.
Let me move it over so it doesn't look so crazy. Okay. Is that better?
Okay. Yeah.
Okay, so. Okay, so we've talked about a mole, right? Do you guys remember what a mole is?
Yeah, molecular number.
Is it molecular number?
It's 6.022 times 10 to the 23rd power.
Okay, so 1 mole
A dozen.
is, what was that?
A dozen,
The 1 mole doesn't equal a dozen, but a 1 mole is like a dozen.
like a dozen.
Okay, so it has similarity to a dozen. 1 mole is equal to 6.022 times 10 to the 23rd. And this is also called Avogadro's number. Okay, now,
AKA, right?
what was that?
AKA.
AKA, oh, also known as, yes.
Yeah.
Also known as Avogadro's number, yes.
Avocado. Ha.
Okay, so we know that 1 mole is always going to be 6.022 times 10 to the 23rd. It's a pretty large number, right?
Yeah.
Okay, now that means if I say I have a mole of girlfriends, how many girlfriends do I have?
Well, a dozen.
0.02 times 10 to the 23rd.
I have 6.02 times 10 to the 23rd. It's not a dozen. A mole does not equal a dozen, okay? A mole is significantly greater than a dozen, okay? So don't make that mistake, okay? So if I have a mole of pennies, how many pennies do I have?
6.02 times 10 to the power 23.
Okay, so now knowing that, right? If I decided I'm going to give you 1 mole of pennies, or I'm going to give you $3 trillion, which one would you take?
The 3 trillion.
You would.
Let me do the math real quick.
The mole of pennies.
Why would you take the 3 trillion, Christina?
Seems bigger.
What was that?
Yo, because 3 trillion is enough to set you up for life
But
and your future generations. You don't really need more than 3 trillion. You know
That's a
what
good
I'm saying?
answer.
why not have more though?
Plus, because you could literally invest a fraction of that 3 trillion and make more money per year just on interest rates that you wouldn't ever need.
But if somebody was going to give you a mole of pennies or $3 trillion, why would you even worry about investing if you're going to get a mole of pennies?
Because logistics, man, when you're talking about a number that big, you're going to have to rent warehouses, property to keep that money. You're going to have to get armed guards. You know what I'm saying?
You can trade it in for, dollars, right?
Trade it
That's
in
what the
to
banks
who?
do.
Most American money is just
You know
enough
what
on
a
green.
mole of pennies, the size of that would be?
Oh, I have a really good idea of what a mole of pennies, the size of that would be. I would love it, I'd be like, what is it? The duck that used to swim in the gold money and all that stuff
Yeah.
back in the old
Scrooge?
days. What was
Scrooge?
that?
Isn't it Scrooge?
Scrooge McDuck, yeah.
I'm pretty sure when we're talking about a mole of pennies, we're talking about like enough volume to fill up like the Pacific Ocean or something ridiculous like that.
Actually, all the oceans,
Yeah, see what I'm saying? Just give me 3 trillion. Give me 1 billion. That's fine. You know what? We'll settle at 1 billion.
Okay. So you do the math. Clearly, if you want the most amount of money, you go with the moles of pennies, right? Because we just divide how many pennies equal a dollar?
100.
100, right? So if I go 6.022 times 10 to the 23rd, pennies, and you said 100 pennies equal a dollar. So then how many dollars do I have?
6.022 times 10 to the 21.
A lot of money, right? Piece of cake. Simple. Okay, so let's use it in chemistry. Okay, a sample consisting of 0.25 moles of ammonia. How many molecules is this? So remember, molecules, right? So moles could be anything that we want them to be. It could be molecules, it could be atoms, it could be ions, it could be dirty shoes. So how would I set this up?
We're trying to figure out how to cancel out the mole of ammonia.
That is correct. We want to figure out how many molecules of ammonia are in a mole.
Right.
So what would I start off with?
Using Avogadro's number.
Would I start off with Avogadro's number, or would I start off with what's given to me?
What's given?
Okay, so we're given 0.25 moles of ammonia. Okay. And then how many molecules are in a mole?
6.022 times 10 to the 23rd.
Okay. So if I want to get rid of the mole, am I going to put mole on the bottom, or am I going to put mole on top?
On top.
I'm going to put mole up here. Okay.
Oh,
so I'll
sorry,
do what you-
bottom.
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 I was looking at something else, sorry.
So then that's going to equal,
I got 1.5055 times 10 to the 23rd.
1.5. How many sig figs should I have?
It should have
3.
3, so 1.51.
It should have 3 sig figs. Are you sure about that?
Oh no, 2. My bad. So it's 1.5.
Okay. So 1.5 times 10 to the
23rd power.
feel like a little kid. Okay, piece of cake, simple.
Yep.
Yes.
Okay, so it's just using that dimensional analysis in the context of a mole, right? Where your units are going to cancel out. Okay. Here. So when we talk about molar mass, we've talked about molar mass already, grams per mole. So basically we're using the periodic table. That's going to give us our grams per mole. Everything was kind of based on carbon, carbon 12 to be exact. And so 1 mole is going to equal 12 grams of carbon. Okay. And then everything from that on was kind of formulated around that. Okay. So if we wanted to calculate the molar mass of calcium fluoride, first thing I want to do is do what?
again, calculate the mass of calcium and fluorine.
Okay. So calculate the, you say calculate the formula mass,
The atomic mass.
the atomic mass. Okay, so, but is there something I need to do before that?
Yeah, get the formula for calcium fluoride.
Okay, so what is the formula for calcium fluoride?
Is it
Is it CAF?
CAF2?
CAF2,
Two.
that is correct. Because I need 2 fluorides to balance out that +2 charge on calcium. Okay, so then Daisy said we need to get the atomic mass of each one, right? So how many calciums do I have?
1.
I have 1 calcium. What is the atomic mass for calcium?
40.
How much?
40.
Okay. And then how many fluorines do I have?
2.
2.
And the atomic mass for fluorine?
19.
My age?
38.
Okay, so we have 40
38.
plus 38.
That's
78.
And the units?
MU.
No, is it AMU?
Oh, molar mass.
So then what would be the units?
Molar mass.
Is it
Grams
grams per mole?
Per mole.
That is correct. Grams per mole, because grams, that's going to be what our mass units are. And a mole is going to be the molar unit, right? Okay, so if you're asked for molar mass, you know you're going to be giving me units of grams per mole. If you're asked for formula mass, you know that you're going to be giving me AMU. Does that make sense?
Yeah, there's no molar.
Piece of cake? Easy to remember? Not too bad?
Not bad.
Okay, I like that. Okay, so, oops, I got carried away. So in terms of the mole, right? If you look here, this is a mole of all of these different components, right? So this is a mole of iron. This is a mole of aluminum. This is a mole of mercury. This in that balloon is a mole of nitrogen. This is a mole of sodium. This is a mole of copper, right? So you can't just look at these. If you look at it, I should say, if you recognize this, they all have the same quantity, right? They have 6.022 times 10 to the 23rd, either atoms, molecules, okay? So they have the same number of atoms or molecules, but they don't weigh exactly the same. They have different weights. And so that's why you're going to see them looking different. They don't look like they're exactly the same, but they have the same number of molecules in each case. That's the same thing here with these compounds here, right? So the copper 2 sulfate, pentahydrate. So that's a mole of copper 2 sulfate pentahydrate. That's a mole of mercury 2 oxide. That's a mole of water. That's a mole of oxalic acid. And this is a mole of oxalic acid dihydrate. Okay, so it's kind of like this. The way I like to look at it is, so if I have apple, I have a cherry, and I have a strawberry, right? Are they going to weigh the same?
No.
No, but I have one of each of them, right? So quantity wise, they're the same, one of each, but mass wise, they're different. Okay, does that make sense?
Right.
Okay, so that's exactly what's happening in this case. Okay, so now that you know how to do molar mass, so we can actually calculate based upon the number of moles. If we know how many moles we have, we can calculate how much something weighs in grams. Okay, so you're carrying out a lab reaction that requires 0.02360 moles of barium chloride. How many grams of the compound do you measure out? So what am I going to do to figure this out?
Convert moles to grams.
I'm going to convert moles to grams. And how would I do that? What would I use?
A conversion equation.
Okay, so
You're
You're
given
given.
0.0360 mole of
okay, so I'm going to start
barium.
off with my given, and that's going to give me my moles, right? But then how am I going to change that to grams?
Your gram per mole,
That's right. My, what is that called?
your conversion.
No, what is it called? It's called
Molecular mass.
is not molecular mass. It's
Molar
called
mass.
molar mass.
Messed up.
Okay, so what is the chemical formula for barium chloride?
BaCl2.
BaCl2. Okay, so I know I'm working with barium chloride. Can I figure out the molar mass of barium chloride?
Yes.
Okay, how would I do that?
Looking on periodic table,
Okay, barium weighs
137.33.
137.33. Okay, and I only need one of them.
Yes.
Okay, my chlorine,
35,
35 point, I believe, 45.
right?
Yes. Correct.
Times 2,
Yeah.
Yes.
and we add that together.
$208.23.
So you said we add it together, we get 208.23.
Yes.
Okay, so, and the units are,
Grams per mole.
so it's grams per mole. Okay, so I want to get rid of the mole, right? So in this case, I want moles on the bottom, so I have 1 mole.
Dr. Henry?
Yep.
Why in this case, round the numbers in the bottom
just-
floor?
Why didn't I round the numbers? Because, well, for one thing, we had 37.33. That 33, it's a third. It's kind of, it's not really negligible. It's like a third of, you know? And then we had, for chlorine, we had 35.45, right? And so
Yes.
that's pretty close. So 2 of those, again, it's not negligible. So in this case, I wouldn't round,
Oh.
I would actually keep it to
Okay.
those decimal points.
Okay.
Because that could be the difference between 1 or 2,
Okay. Thank you.
So I want to get rid of the number of moles. So I want to put my grams on top because I want grams. Okay. What do you guys end up with?
7.4963. And with
7
four
point.
sig,
How many sig figs?
4 sig figs.
Are you sure?
3.
Yep. 1, 2, 3.
Keep messing that up.
7.4963. So 7.4 on 4. 7.50, right?
Yeah, it would be 7.50.
And the units would be grams of barium chloride. Okay. How do you guys feel about that? Is that okay? You got it? You're feeling comfortable? Is it temperature a little hot, a little cold? Or
That's
just
good.
right?
Just right.
Just right. Okay. 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 Take home message. So if we're given units, meaning quantity, if we're given molecules, atoms, ions, hot Cheetos, right? That's going to be quantity. So we have to use Avogadro's number to go from quantity to moles. And if we're given moles and we want to get to mass, we're going to have to use molar mass. Okay. And it can go the other way around too. If we're given grams and we want moles, we're going to use molar mass. If we're given moles and we want quantity, we're going to use Avogadro's number. Does it make sense?
Yeah.
Yep.
Yes.
Okay. This is just basically saying exactly the same thing, only thing using these big old boxes to help us understand it. So this process, right, we're getting you guys to the understanding the general pattern of stoichiometry. Stoichiometry is using chemical equations to sit there and figure out how much you're going to be generating. Okay. Okay, are you guys ready? Let's go. See how well you guys got this down. Determine the mass in grams of 3.2 times 10 to the 23rd molecules of sulfur tetrafluoride. What do I need to do? What is the first step?
You need the formula for sulfur tetrafluoride.
Okay, so what is the formula for sulfur tetrafluoride?
Would it just be SF4?
That is correct. Okay, so I have the formula. So then what am I going to do?
You're going to break it up into how many sulfur and how many fluoride you have.
So I'm going to calculate my molar mass. Okay, is that what you're telling me? Or how many sulfurs do I have?
1,
Fluorides?
4.
Okay, so 1. The mass of sulfur?
32.06.
The mass of fluorine?
Is 18.998.
So can I just say 19?
Yeah.
Okay.
You're going to add them after you multiply them.
Okay. 76.
76 plus 32.06 is 108.06. 108 grams per mole.
Okay. So we calculate the grams per mole. So now what am I going to use that for?
For our conversion, because we need to determine the mass in grams.
Okay, so then what am I going to start off with in terms of our conversion?
You are going to start off with your given.
My given. Okay, so I'm going to start off with my given. So 3.2 times 10 to the
24th.
24. That's molecules of SF.
Yeah.
Okay,
Okay. Then you're going to put your, your moles on the bottom.
I'm going to put my moles on the bottom, but I have molecules on top. Are moles and molecules exactly the same thing?
You're going to put your molecules on the bottom.
Oh, I'm going to put molecules on the bottom. How many molecules am I going to put on the bottom?
One, right?
Am I going to put only one molecule?
Hold on.
Are you saying one molecule equals 1 mole? Is that what you're telling me?
12.
Why am I going to put 12? 12 is a dozen.
I'm stuck on a dozen. Oh, God.
Would the bottom be the 6.02 times?
Okay, it's going to be Avogadro's number, 6.022 times 10 to the 23rd. Oops. And that's molecules.
Mhm.
Oops. And what's going to be on top?
Grams.
Grams?
Or
Because Avogadro's number is what? What equals to 6.022 times 10 to the 23rd?
grams
Mole.
is 1 mole.
1 mole. Okay, so now I got things in terms of moles, right? Because my molecules are going to cancel out. And then I have a mole of SF4. Okay, so then how can I get grams?
You grab the molar mass?
I use that molar mass that you guys calculated earlier. That is correct. Okay, so I have moles on top right now. So if I want to get rid of my moles and get to grams, what do I need to do?
Cancel out the mole?
Okay, so I have 108 grams per mole. You guys know that means like grams per 1 mole. So that means I'm going to put the mole on the bottom. Is that what you're telling me? That
Yeah.
1 mole. And then I'm going to put 108 on top.
Yep. Wait, 108 or 108.606?
100, you could use 108.06.6 or you can use 108. It's going to be about the same, right? Because that 0.06 isn't going to change that much, but if it was a third, like if it was 0.3, that could make a difference.
Okay then.
Okay.
Would it be safe just to like leave all the numbers and do the math that way?
Yep, you can leave all the numbers to do the math that way if you want to be safe. But you're going to end up with sig figs anyway. How many sig figs am I going to have in this case?
2.
I'm going to have 2 sig figs, right? Okay, so if we do that math, what do you guys get?
573.8957.
Okay. So 573. Okay, so sig figs, you told me I needed 3 sig figs.
Two.
So my
Two.
answer, oh,
7.
2 sig figs. Okay, so my answer should be 570 grams of SF4. Piece of cake?
Dr. Henry, is this part of the next exam or is this on the exam for tomorrow?
This isn't going to be on your exam for that opens up tomorrow. This is going to be on your next exam.
Okay, thank you.
But if you want it, I can change it, you know. I'm flexible.
I know, but no.
No, it's okay.
Okay? Questions, concerns, Cash?
Above. So the 108, are we multiplying that, or are we dividing, or are we multiplying?
You're multiplying it, right? So things that are on the top are going to be multiplied across, you know, and then you divide by the stuff on the bottom.
So I would multiply the 108 by the 3.2 times the 10 to the 24th, and then divide it by the
Yep.
mole.
And then you divide it by 6.022 times 10 to the 23rd.
Okay.
Yeah, because if you divide by 1, you want to pay attention to the numbers when you're doing that, right? You want to make sure that your units are canceling out, but you want to pay attention to your numbers. So in this case, that mole's canceling out, that 1 mole, right? Okay, so you don't have to worry about those. You have your 3.2 times 10 to the 23rd times 108 divided by 6.022 times 10 to the 23rd. Okay, so that line is kind of like a fraction, you know, like fraction means division, right? So if I have 4 halves, that's really just 2, right? 4 over 2.
Okay. Yeah.
Okay. Okay, you guys ready to move on?
Yeah.
Something harder? Good. Good. Okay. Our next topic, percent composition by mass. So percent composition is its parts over the total times 100, since we're talking about percent, right? So okay, so if we're calculating the percent mass of fluorine that's in calcium fluoride, the way that we would go about doing that is the first thing that we want to do is determine what?
The formula mass first.
We would want to determine the, well, we want to determine the formula first because we can't do the formula mass without having the formula. So what is the formula for calcium fluoride again?
CaF2.
CaF2. Okay, so then we want to calculate the either a formula mass or the molar mass. Okay, CaF2. Okay, so if I have 1 calcium and 2 fluorides, calcium weighs what again?
40?
40.
40?
Okay. And then fluoride weighs,
19?
and there's 2 of them. So I
Yeah.
have 19
Times 2.
times 2. I add these guys together. So that's 78, right? Sorry, I ran out of room at the bottom. Grams per mole. So if I want the fluoride in this, I would just take how much of the fluoride I have. I have 38. So 38. So 38 grams per mole. Over my total, which is 78. grams per mole.
Because we're doing grams per mole as opposed to AMU.
Yep.
How come? I don't see that.
Because we're talking about percent mass, right? So percent mass could be formula units. You could use formula units, or you could use grams per mole. It doesn't matter in this context. Are you going to be working things on the microscopic scale, or are you going to be working on things on the macroscopic scale? Most likely.
Macro.
Okay. So I multiply this times 100.
Okay.
And I get, my watch is telling me I need to breathe.
Breathe.
Just excited.
That just for the A because we have fixed.
Well, since we're using the molar mass, right? Since we're using the molar mass from each of the ones, the atomic mass and the molar mass, and they've been rounded anyway. So in this context, you don't have to worry so much about sig figs in this context, because none of them are truly given to you. They're given to you on that table, but that table is, depending on the periodic table that you have, it may round different. Does that make sense?
Yes.
Okay.
After
in other
the
words,
48, Dr. Henry, is that a 1 or a 7?
That's a 7.
Oh, a 7?
Yeah, that's 48.7.
I got 48.1.
48.1.
Yeah, well, in the calculator, what I did is I put parentheses first, and then I added the 38 divided by 78, close parentheses, times 100, and that's how I got.
Let me check. I may have made a mistake here. Could be right.
I had 48.7.
I got 48.7. 48.717.
Yeah, same.
Okay, so then that would give me my
Wait,
percent.
I'm wrong. I typed it in wrong.
That's all right.
Yeah.
So that would give me my percent fluorine in the calcium fluoride. Okay, so questions, concerns, Cash?
Could you just do me a favor and raise up that bottom part really fast?
Yeah.
Thanks.
Funny, I'm in the lab right now, so it's a little bit harder for me. I'm not used to writing on this desk. And so I've been spoiled with my little table at home. So
I know, I was going to ask you, how's it feel to be at school again?
it's weird, really weird. And it's also really weird because the lab is so clean, although we did make a mess a little bit. So. It's getting homey now. Let's see.
Click off the little bubbles.
Yeah. Okay. Okay, so let's clear this. Come on. Okay, calculate the percent composition of mass of aluminum sulfate. First thing I have to do is do what?
Get the formula for aluminum sulfate.
Okay, so what is the formula for aluminum sulfate?
It would be Al2.
Oh, you guys figured, what was that?
Al2.
Al2.
Parentheses. SO4. Close parentheses. 3.
Okay, so that gives me my formula. So if I want to calculate the percent composition by mass of aluminum fluorate, of aluminum sulfate, basically I want to find the percent of each of the different elements in there. Where would I start?
Find the molar mass.
Okay, so how do I find the molar mass?
List each individual element and find their weight or their.
So I have aluminum. I had sulfur. How many sulfurs do I have?
3.
How many oxygens?
12.
12.
Okay, and what is the mass of aluminum?
Rounds to 27.
27 times 2. 54. Is that correct?
Yeah,
What is the mass of sulfur?
32.06.
Would be 32.
Times 3.
Yeah. 96.
The mass of oxygen
16.
16.
times 12.
192.
We add it all together.
342.
Okay, so if I wanted the molar mass of, if I want the percent composition of aluminum in aluminum sulfate, what would I do?
It would be would it be
54.
54 divided by
342.
divided by 288?
288?
Because you add up the 96 and 192.
No, when you add up, you'd add up the whole thing. Remember, it has to be the total.
342.
Oh, okay, so 242 times 100.
Okay, remember, it's only the part time divided by the whole, as in everything. Okay? And what do you guys get for that one?
15.7895.
Okay, 15.78. So let's go 15.8. And that's Al. Okay, what about the sulfur?
96
96
over 342.
over 342.
Times 100.
And that equals
28.1.
so, and that's sulfur.
Yeah.
And if I wanted to calculate the oxygen, there's two ways of doing it. I could do the one way of using the 192 divided by the 342 times 100.
Or could you just also add up the aluminum and the sulfur and subtract that?
That is correct. That's the other way of doing it.
Cool.
Yep. So let's see. You mean subtract 100 from that?
Add them up together and subtract it from
100,
Yeah.
right?
100.
So, or like I said, we could do the aluminum, so 100% minus 15.8% of Al minus 28.1% of this. And that's going to equal okay, piece of cake. Yes, no, maybe.
Yes.
Yeah.
Okay. Okay, let's see. Oops. Okay, so aluminum chlorate is 38.3, 35% chloride. What mass of aluminum chlorate is needed as a source of 50.0 milligrams of chloride? Okay. So how would I go about doing this?
First, find the formula for aluminum chlorate.
Okay. What's the formula for aluminum chlorate?
It would be Al parentheses ClO3 close parentheses 3.
Okay. So the question asks, what mass of aluminum chlorate is needed as a source of 50.0 milligrams of chloride? And we know that aluminum chlorate is 38.35% chloride. Okay, let's look at the definition of percent mass, because this is what that's giving me. This is my percent mass of chloride, right? Is that true?
Yes.
Okay, so the definition of percent mass is, if I was talking about this, it would be grams of chloride over grams of aluminum
Chlorate.
chlorate. And we know, because they told me, that that equals 38.35%. Oops, I forgot to multiply it times 100. My bad. Okay, so is there something given to me already?
Yeah,
What?
38.35%.
Okay, that's given to me. Yeah, I got that. Anything
And
else?
50.0 milligrams.
Okay, so if I have my upper part is milligrams,
Mhm.
so that's 50.0, and we have to keep the units the same. So if this is milligrams, then down here we can also have milligrams, right? So this is what I'm looking for, right? Can I solve this equation?
Sure.
I can. So what do I need to do to solve the equation? So
Cross
we're gonna
out
use-
your milligrams.
Okay. Is that really what I want to do?
Want to find the molar mass of like aluminum and carbon of the molecule?
Okay, so if I look at this in terms of a simple algebraic equation, right? So right now I have a value of 50 on top. I have X, that's going to represent my grams of, or my milligrams of aluminum chloride, right? Times 100. So I'm going to use a dot here since I used X.
So would you be just trying to get the X by itself, essentially?
Exactly. I'm just going to try to get the X by itself.
So like dividing 100 and like multiplying like that stuff?
Yep, exactly like that. So let me make a little more room. Okay, so if I go ahead and solve this equation, I get X 38.35 equals 50 times 100.
$5,000.
And so
And then we divide by 38.35. That's 130.4 because we want 4 sig figs, right?
we would
No, we
want,
want three.
yep,
three.
nope, you're right. Yeah, three sig figs in this case. So then it would be, you said 100 and what?
130.
130?
Yes.
Okay. Oops, milligrams. Okay, piece of cake. Yes, no, maybe.
Maybe.
Maybe. Okay. Not too hard, not too easy. Want
I
something
agree.
harder? You want something a little bit harder, right?
Sure.
Okay, good. Okay. Okay. Skip something. Okay, the next part that we're going to be talking about is called empirical formulas, right? Let me kind of explain to you what empirical formulas are. I should say, did everybody get that down before I erase? I'll even go back. Everybody got that down?
Yeah.
Okay, good. Okay, clear. Okay, so empirical formulas are, it's the lowest integral ratio of an atom in a compound. So like, for instance, if we have C6, H12, O6. Now, all of those numbers are divided by 6, are they not?
Yes.
Okay, so the and that's the most that we can divide them by, right? So the empirical formula for this guy would be CH2O. Okay, so it's the lowest integral ratio between the elements in that compound.
Okay.
Okay, so what would be the empirical formula for this guy?
C2H5.
Okay, what about that guy?
C2NO.
Okay, simple, not too hard.
Yeah, simple. I thought you were going to give us hard stuff.
Don't worry, I'm building you up to it.
I'm just kidding. No, I actually like these. Those are fine. Make the exam full of those.
Okay.
I like these too.
So when we're trying to determine the empirical formula, sometimes we may need to determine the empirical formula by using mass percent. Okay, so we'll use how much mass percent are in the ratio, or we may use molar. We have to change that mass percent into molar to kind of actually get the actual empirical formula. So we'll need that molar ratio between them all. Okay, because when we think about those numbers, they're quantity, right? They're not mass. So if we're given that mass percent, we're going to have to change that to moles because we want them in terms of that quantity. Okay. So let me give you an example. So a sample of pure, I don't know what just happened. A sample of pure compound made up of 1.61 grams of phosphorus and 2.98 grams of fluorine. Find the empirical formula. So a sample of a pure compound is made up of 1.61 grams of phosphorus and 2.98 grams of fluorine. So basically, I'm telling you that this compound is made up of phosphorus. We'll use an X. And then it has fluorine, Y. So we're trying to figure out how much of the X and the Y that we have. Okay, so how much phosphorus is in that compound and how much fluorine is in that compound. So the way that I would do this is I start off with my mass. Of phosphorus. So what is the molar mass of phosphorus? Because I want to change it to moles.
31. 31.
So it's 31.9.
No, just 31.
It's 31.
So 31. And that's going to equal 1 mole of phosphorus. Okay. And then my fluorine, if we do that math, what do you guys get?
19.
You get 19?
Oh, sorry. No.
That's 0.05.
How many sig figs should I have?
3.
So 0.05.
2.
519.
Yes.
Okay, and that's moles of phosphorus. Okay, and then for the fluorine, I have 2.98 grams of fluorine. And what is the molar mass of fluorine?
19.
Should say the atomic mass. And you guys get?
0.157.
7.
Okay, so at this point, you're going to figure out which one has the smallest number of moles, phosphorus or fluorine.
Phosphorus.
So phosphorus has the smallest number of moles. So what we're going to do is we're going to divide both numbers by the number of moles of phosphorus. Okay, that's going to equal 1 phosphorus. So what do I get for fluorine?
$3.025.
Okay, and we know that those subscripts can only be a whole number, so it's 3.025, so 3. So then my chemical formula is Pf3. Now, this is going to be important. We had the actual number that we got was 3.0. You said 85?
25.
25. Nice small. 25, right? So we can easily round up that to a whole number of 3 without being a big problem. When I start getting to the point where it's 3.25, that's going to be a problem. Or 3. We'll say anything that's greater than 3.1 and above, it's going to start being a problem. Okay, because that means that you have numbers that are not evenly divided, and so anything that has that like 0.1 and above is going to be a problem, and I'll explain that to you here in a second. So do you guys get this so far though, like this part and how you got that? Okay, so let me explain this to you. So if this number is, let's say, a third, 0.3, right? So if it was 3.3, in that case, we would try to figure out what number we need to multiply this by to make it a whole number, right? Because that means that it's not, you have an even and an odd number, or you have a number that isn't readily divisible by it. So if I had 3.3, what number would I need to multiply that by to make it a whole number? So instead of this being, let's say, kicks and giggles, I ended up with this value here. $3.3. Okay, so let's say this number here was 3.25. Okay, so if this number was 3.25, instead of this value. You end up with 1, so 0.17.
7-1.
Okay, now if I divide that by 0.0519, I get 3.3. Okay, so in this case, that number is such a high number that I'm gonna have to, I can't just round up or round down. I'm gonna have to take it in consideration. So then I need to figure out a number that I can multiply this by to make it a whole number. So I can end up with one whole number. So what can I multiply 0.3 by to make it a whole number? So let me see if I can change this. So if I have 0.3 times what number times x is going to give me 1. Or let me give you a better hint. 0.33 times x equals 1. So if I multiply it by 2, what would be the answer?
6.6.
0.66, right? If I multiply it by
Oh,
3,
sorry. Yeah.
what would it be?
That would be 0.89.
0.99. Is that close enough to 1?
Yes.
Okay. So if I multiply this guy by 3, that gives me what?
1.
3.3 would be what?
Oh.
9.9.
9.9. So then I could just say 10, right? Because it's,
Oh, okay. I was like really trying to find something that made it a whole number exactly. So I didn't know. So 9.9 roughly is the next one. So we could just do that.
yeah. Okay. So it's close enough that I can make, or I'm okay with rounding that out. So if I have to multiply this guy by that number, I have to do the same thing to the other. So what I do to this one, I have to do to this one. So in other words, I have to multiply this guy by 3, and I have to multiply this guy by 3. So if I multiply this guy by 3, then I get 10, right? So in this case, my chemical structure would be P3F10. Does that make sense?
Yeah.
Okay. So I'm going to go to a whiteboard. Real quick, maybe. Okay, so I'm going to give you guys this little cheat sheet. So if the number is 0.2, or it's a number and 0.2, what can I multiply that to equal 10? I mean, equal 1.
5.
If it's 0.25, what can I multiply that by to equal 1?
4.
If the number is 0.33,
Times 3.
if the number is 0.5,
2.
if the number is 0. Six, six.
Four.
If I multiply by 3, what would that be?
1.98, roughly
1.98, right? Or
2.
okay.
So,
And then if the number is 0.75,
mhm.
if I multiply this by 2, are you sure?
4.
Okay,
So it doesn't really matter like how high you go up as long as it hits a whole number.
that's right. So you want to make sure it hits a whole number. And it does matter because, you know, you're not going to be multiplying it by 10
You want
usually, right?
The lowest.
Yeah.
Okay.
Yeah, so you're going to be, if you look at it, right? So 2, 3, 4, and 5. That's typically what you're going to be multiplying it by, because all the other numbers are going to kind of be multiples of each other. So okay. So
And, like,
if
what
it
if-
ends in 0.8, you're going to multiply it by 5. If it ends in 0.75, it's going to multiply by 4. Okay.
What if it doesn't land on any of those numbers? What are you gonna multiply by?
It usually lands on somewhere in there. But if it's 0.1, you know you're just going to round in that case.
Okay.
Right. Okay. Okay. Let's see. Where are we on time? I got 8 minutes. Okay, so now when we're given percent mass, in the case of nicotine is 74.1% carbon, 8.64% hydrogen, 17.3% nitrogen. What is the empirical formula? So again, in this case, we were given percent mass. Now we can sit there and make some assumptions, right? So we know that it's percent mass, right? So we're saying the total altogether, if we're saying altogether, we can make an assumption of how much nicotine do we have. If we know that 74.1% of it is carbon, 8.64% of it is hydrogen, and 17.3% of it is nitrogen. So what is a logical assumption that I can make about the nitrogen? I mean, about the nicotine?
Is that it's the majority percent?
It's
Carbon.
gonna, what was that?
Carbon is
Carbon's going to make up the majority.
Carbon is gonna make up the majority, okay?
Mhm.
So, but if I add them all together, won't they all make up all of nicotine?
Yeah.
Yes.
Okay, so if I made an assumption and I assumed that I had 100 grams, how many grams of it would be carbon?
74.1.
Yeah.
Okay, so let's go ahead and make that assumption. So I have 74.1 grams of carbon. I have how much hydrogen?
8.64.
And then how much nitrogen?
17.3.
Okay, so first thing I want to do, because I need to be able to compare moles to moles, is to do what?
Moles to moles.
I have grams.
Convert
So-
using their mass.
Okay, use their atomic mass. Okay, what is the atomic mass of carbon?
12.
12.
Okay, so it's 12 grams. Carbon per 1 mole. Carbon. Okay, so my grams of carbon are going to cancel out. So 74.1 divided by 12.
6.2. No, that's 6.6.
6.175.
Do sig figs matter, Dr. Henry?
Sig figs matter. So how many sig figs should I have?
3.
3.
So then that should be
6.18.
okay. And that's moles
Moles
of carbon.
of carbon.
Okay, now for hydrogen.
1/1
1/1.
equals 8.64 moles of hydrogen.
Okay, and then nitrogen.
14.
So it's 14 grams
Mhm.
at the bottom and 1 mole on top.
1.24 grams, moles, I mean, of nitrogen.
So my last example, what did I do?
You converted.
I converted.
You didn't convert.
Divide
You
by the
The
least.
lowest.
I divided by the lowest number of moles. That's correct.
number of moles.
Mhm.
Okay, so what is the lowest number of moles?
1.24.
1.24.
Okay, so we want to divide everything by 1.24. Okay, this is an easy one. So that's 1 nitrogen. .64 divided by 1.24.
6.97.
6.96.
Okay, so that number there, is that close enough to 7?
Yeah,
Yeah.
let's just roll with 7.
Mhm.
So 7 hydrogens. Okay,
Yeah.
and then my carbon.
That's 5.
5.
Okay, so my chemical formula would be C5, or my empirical
Five.
formula would be C5, H7.
7.
In.
And
All right, we finished. Woo.
Piece of cake.
Yeah,
mhm.
bitter cake.
It's a bitter cake.
It's not sweet.
Oh, it's so
I'm
sweet.
getting
So,
I'm
so
getting
sweet.
salty over this stuff. No.
I don't think it's